Okay. So uniform rod AB of length 4 meter weighs 20 newtons is suspended horizontally by two vertical strings attached at A and B. Particle of weight 10 Newton is attached to the rod at point C. Okay, so first let us start with the rod. Okay, the rod is AB, its length is 4 meters and weight is 20 newtons. So 20 newtons will act at the center. Okay.
Yes.
Then it's attached by two vertical strings at A and at B. So at A we have one rod. Let's change the color. This is the string at A and B. Particle of weight 10 Newton is attached to rod at point C such that AC is 1.5. AC is 1.5. 1.5 means this total is 2 now. 1.5 means somewhere here, you know. So this weight is 10 newtons, correct? AC is 1.5. So this is point C. AC is 1.5. If you take this point as something like M, AM will be how much? AM will be 4 by 2, that is 2. And particle is moved so that the rod remains in horizontal equilibrium with the tensions in the string at B 1.5 times the tension in the string A. So first let's first do this bit, find the magnitudes of tensions. So let us say this is tension TA and this is tension TB. Both will be acting upwards, right?
Yes.
So first let us solve this. In order to solve this, again we will have to take two equations. First equation, sigma vertical. So TA TB are acting upwards. Minus 10 minus 20 equals 0. So TA plus TB will be 30. And then we have to take moments. We have to take about point A or about point B. Let's go with point A. A is simpler. So 10 times distance is 1.5. This is clockwise, so minus 20 times 2 and it is again clockwise, and TB times 4, this is anti-clockwise. Total should be 0. So TB 10 into 1.5 or 20 times 2 is 40 divided by 4. To do this, one minute. Huh? So 13.75 newtons. And then if you substitute this back here, you will get the value of TA. TA will be 30 minus 13.75. So find this 16.25, correct? So TA, sorry, this is TA and TB, both we found. So next bit is asking the particle is moved so that rod remains in horizontal equilibrium and tension in the string, the ratio is given. Fine. So this is A bit, and now in B bit AC doesn't remain 1.5. Fine. For B bit AC becomes a variable X. AC becomes a variable X. Okay. And the tension in B is equal to 1.5 times the tension in A. Okay, so this relation we have to use in order to find distance x. Okay, once again we have to take moments about the point, yeah, moment about A. So 10, now this times instead of 1.5 we have the distance as x, and this is clockwise, so minus 20 times 20 times how much, 4 by 2, that is 2, and this is again clockwise, sorry. And then TB distance is 4, this one is anti-clockwise, so plus, total should be 0. Again there are two variables here, so we will not be able to solve it. So in order to reduce it, let us take sigma v. Sigma v means tension A upwards, tension B upwards, minus 10, minus 20, the total should be 0. Now let us substitute the value of B given by this equation over here. So TA will remain the same. In place of TB, we have to take 1.5 TA equals 30. Okay. So TA will be 30 divided by 1 plus 1.5, that is 2.5. What do we get here? Okay, so now substitute this TA value. Okay, TA we cannot substitute because we have TB here. So first let us find TB. TB is 1.5 times 12, 18. So let us substitute this over here. Then you get the value of x. Okay, so 18 times 4, and all the negative terms let's send to the other side. We get 10x, and this minus 20, that let us keep it this side only. So x will be equal to, and this, so minus 40 plus 18 into 4 divided by 10, that is 3.2 meters of. Okay, so this is our answer.